Okay, so thank you all for joining us this evening on the fourth of our fifth series for the professional learning series from the Georgia TESOL. On this series that we've been exploring through the month of June, that we've been talking about integrating content and language in different content areas. So we began at the beginning of the month with Dr. Elizabeth Webb, our illustrious president. That really kind of set off the series by talking about doing a deep dive into the WIDA, the ELD standards and sort of the frameworks and how they work and all of that. And then in the subsequent meetings, we've been talking about ways to integrate content and language into specific content areas. So this evening we have with us Laura Canepa-Redondo, who is the Science and ESOL Program Specialist for the Georgia Department of Education. And so her presentation is on decoding skills in science and scaffolding language, content and language within the content area of science. So Laura, over to you.
Thank you for that wonderful introduction. Like he stated, my name is Laura Canepa-Redondo. I am the Science ESOL Program Specialist at the Georgia Department of Education. I am one of 4 team members on the science team. I do have a colleague in the Content Integration Special Education Specialist for Science, and then a Science Program Specialist is Renee Shirley-Stevens. The Content Integration Specialist is Judy Baccaro, and our Program Manager is Keith Crandall. So we are the science team at GaDOE. Ways to always stay in touch with us. I want to go ahead and just put my email out there at the beginning, because sometimes we get so much information throughout that at the end, the last slide, even though you will see my email again at the end, I like to have it here at the beginning so you know exactly how to contact me or contact any of us. Another way to stay in touch with us is to join one of our mailing lists, our listservs. There's 3, one for different grade levels, or you could join all 3 depending on your role at your school. And we do have social media. We have a Twitter that you can also follow us there at GaDOE Science. So I wanted to start off with decoding in science. And when I started teaching, I'm a science teacher. My background, my foundation, my whole schooling, I'm a scientist. Okay. I went into secondary science education. I taught in high school, and I was like, yes, science information, science knowledge all the way, and getting kids going to the science field. But then I started early on in my teaching. I had a lot of students who were multilingual learners, and I taught at schools with high density populations of ELs. So I started thinking about, how can I develop meanings of words, especially academic words in science? So I started going down this route of decoding words. And as I started to look at more information about decoding, it's more about the morphological decoding or morphological awareness of words. So I'm also putting on my science hat, because I'm looking at this word of morphology, and I could break it apart and kind of put together what this word means. Because at first I'm like, I have no idea what morphology is. I'm a scientist. So I'm thinking, okay, ology. I see ology all the time as a scientist: biology, geology, psychology, entomology, meteorology, microbiology, et cetera, et cetera, et cetera. So I know that the suffix of ology means the study of. Then I'm looking at morph. I'm thinking of other words I already know that has part of the word of morph. So I think of metamorphosis. Once again, I'm a scientist. So a lot of these words are in kind of my bank of knowledge already. So metamorphosis, with how a organism changes forms over its life. Or we have metamorphic rock also, where it's a changing of the form of the style of rock. So this part of the word must mean some type of form. So I'm putting together a meaning, thinking that this word of morphology is the study of forming words. And then as I'm kind of checking myself, did I put together the meaning of this word correctly just by looking at the different parts? So, by definition, morphology is the study and description of word formation, such as inflection, derivative, and compounding in language. So, this is the track of how I'm going with explicitly teaching language development in a science classroom and taking the time of separating and breaking apart these words to then put together meaning of the entire academic word that we need for science. Now, if you're an elementary teacher, you probably have seen these matrices before. You have your root word, you have your suffixes, you have your prefixes. Um, prefixes on your left, your suffixes on your right, and you can have many different ones, and you have them in combination with your root word, and that gives you different meanings of the word. Now, we'll see this again in a couple of slides, but that is I guess the template you could say of how you could break apart the words. Now, I taught secondary science, so in my classes, I always started off with language objectives because I also taught the sheltered content courses, so science courses, but I always had all the multilingual learners in my classroom. So we started off with our language objective for the day every single day. We looked at what are we doing, what are we going to be engaged in utilizing, are we always listening, are we reading, are we writing, are we speaking, and we kind of look for those kind of keywords, those context clues in our language objective for my kids to really know what are they going to be utilizing this today or in this activity. Until one day I had a kid and he stopped me in the middle of our language objective review and he goes, "Miss, is ing similar to when we say ando?" And his primary language is in Spanish. And I was like, yes, because it's like listening, because ando is like the suffix in Spanish when we say caminando or hablando or escribiendo, it's ando at the end. And he's like, is it the similar in English when we say ing? And I was like, yeah, I was like, light bulb. Yes, that is exactly the same meaning of how it is in English because we are listening, we are reading, we are writing, we are speaking. We're in the moment of doing that action. So if you're reading, you're leyendo. So if you're listening, you're escuchando and writing. And then he kept going through it. It became a lengthy activity. He just had it in his head the entire time. He went from walking to eating to he just started saying all the different words and adding the suffix of ing on it. And it's one of the most bright connections I remember in all my kids' stories. One of those light bulb moments that you think of your kids, and I'm like, oh my God, this is not even a science moment for me. This is a language development moment. This is a connection across languages. And he made this connection of the the purpose of using ing by connecting it with the purpose in his primary language. Which brings us to um, one of WIDA's main points or big ideas is functional approach in language development. So I took this quote out of the framework. It's also linked here. So once you have access to the PDF and all the slides, if you don't have the link for the PDF of the framework, it is available here. And it says the explicit teaching of how language works can help multilingual learners expand what they can do with language, thereby growing their language toolbox. The result is that students become increasingly aware and strategic in their use of language to negotiate meaning and achieve their purposes in various contexts. So me thinking about the students that I have had in the past, especially the one I highlighted, now he knows how to use that suffix in the correct context. And it's not just in my science classroom, but in any of his other classes, math, literature, social studies, in the hallway, we're just socializing, and he's able to put together the correct use of the word. Now, I'm going to go through a lot of different uh, vocabulary words or academic language words, and how we could break them up into different parts of a word and then bring them back together into the meaning of how to use it in science classes. So a lot of the pictures you will see will be in um, secondary classroom settings, especially with biology or environmental science. So here we have one where we are looking at macromolecules. And when we look at macromolecules, we always talk about monomers and then polymers. So I'm always breaking down where can we find prefixes and how can we pull the meaning of a prefix so then we could construct the meaning of the science word. So here we have monomer, polymer, which goes with the numeric value of 1 for mono. If we have 2, it's di. Poly goes into many. And then whenever I have an opportunity to always connect it to another content course, because they know poly from math class, I pull that in as well. So and I always ask the kids. The kids know. I don't just always give them the answer either. The kids, we build the meaning together. So they know poly from polygon, and so they know miss. That means many. That means more than one. And then as we are looking at macromolecules and we're looking at monomer, so now we know the kids know half the meaning already because we're dealing with the numeric number of one. So one, and then we're like one of what? So we're looking at one molecule. These are the building blocks. And then polymer is when we have many of those building blocks connected together to make one big molecule of our macromolecule. And that's another example I always have with the kids because I compared macro to micro. So we have small versus big. So now here in the second image on the right, we have a specific macromolecule that we're looking at carbohydrates. So its monomer is a monosaccharide. So again, we could split the prefix and now I'm telling my kids, look, what does this mono mean? Miss, it means one. So then I introduced the second part of the word of saccharide, which is a little bit more academically challenging at a high school level. So letting them know it's a sugar. So put it together, they know that this word now means it's only one sugar. Same thing with the polysaccharide. After that, I let them construct the meaning and tell me what do you think a polysaccharide means by breaking up the two parts of the word. Then we have examples with different monosaccharides, different disaccharides, and different polysaccharides. And building it up, they could go from one sugar to two sugars. And then we have a chain of many sugars. Another common, I guess you could say nomenclature in science is the suffix of "-os." When we highlight the suffix of "-os, that always relates to a sugar. So that's something that I always highlight. So they identify that it's a type of sugar, and it's one sugar, or it's two sugars, or is it a polysaccharide with many sugars connected together. Same thing here. We have a couple of other examples. And you will also notice that I start doing a lot of different colors. I usually have all the colors on the dry erase board, and we break them apart. Since we have biotic and abiotic, we have bio, that means life. Later on in one of the slides, you will see that ick. I also bring it's a state of being, so it's a state of life, so it's living things. Then we have the prefix of a, and it's abiotic, so it's bio's life. A is not or no, so it's no life, non-living. And even another example here on the lower part of the screen, we have the different spheres. I break them up with hydrosphere, geosphere, atmosphere. We look at hydro, meaning water. Sphere, I put the shape of a sphere because then we're connecting it to a cycle or the roundness of how it's cycling through the earth, hydrosphere, and geosphere, meaning earth, the grounds and the land, the rocks, and an atmosphere, how it's related to the air. Now, here, when we also think of biology and we think specifically with like DNA, and we think of the double helix versus when it's all coiled up, we think of it, we call it as a chromosome, as a coiled DNA. But there's a lot of words that sometimes are used interchangeably that kids will get confused with because, oh, one time you used the word coiled, but now you're using the word fold. And so it's showing them that they are all synonyms of each other, of fold, coiled, and then wound, versus when we have the prefix of un, then it's unfold or uncoiled and unwound. So I always have images at the same time when we have a coiled DNA versus an uncoiled DNA and how it looks like. Something else I like to point out when you are coming across these examples, because a lot of another way to introduce vocabulary, which is very important in science, is to introduce it while in the context of when you're doing it. So when we're coming across these words, especially words that are homophones or homographs, I point them out because here, um, I have had kids say, "Miss, you said wound, but that's a wind, like the wind blowing in the air." And I'm like, yes, that's exactly how you spell it, but we have a different pronunciation because it's a homograph and we have a word that has a different meaning. And you're going to pronounce it differently because we are using it in a different context because we're talking about the way it's curved or winded up and twisted and folded. So it's a synonym to these words. And we're not talking about the wind that you feel in the air. So it's wound versus wind. So when you have homographs, and I even tell them how why homographs come about is because they are written, they have the same spelling. We have a prefix that means same and graphs that are related to spelling so that you have the same spelling, you have the same letters, but you have a different pronunciation. And it's pronounced differently depending on the context of how you're using the word. So, and always point that out explicitly in the middle, like if it comes across, point it out. So part of having explicit language instruction is that's a way you can incorporate it even in your science classroom. So here we have photosynthesis. You could see how I break apart photo for light energy, synthesis to make. Another part here, the image lower on the screen is aerobic and anaerobic. I tie aerobic with arrow for air, and a lot of students who have their primary language as Spanish, I ask them, what does this word look like in Spanish? And eventually they get like aeropuerto for like airport or airplane, and then they get to air. And then here with anaerobic, we have a prefix of an that means not or no, so then we have no air. And in both situations, here it's the core idea of cellular respiration. So instead of all of the air molecules, we're specifically talking about oxygen. And then back to the image on the top part of the screen, whenever I develop a full length definition on the board, it's always co-constructing with my kids. I ask my kids how we're going to put this definition together. So here we need to use the words make, and we also need to use something for light energy. So when we are looking at photosynthesis, and it's the process of an organism to make its own food, and food, we go back to glucose because it's the sugar, and they're using the energy from the sun, which ties back into light energy. So if we construct a definition, I always have them point out the pieces of the word of how they put the meanings together. Similar situation here. This is a phospholipid. Phospholipids are part of the cell membrane, and in the cell membrane is a phospholipid bilayer. So we have another prefix to introduce the numeric value of 2. So they would see there are 2 rows of the phospholipid that will create the cell membrane. Now, if we look at one single phospholipid, we can even look at the different properties of the different parts because we have a a head part of the phospholipid, and then the tail part are the fatty acids. And we think lipids are fatty. So that's why it's also connected, or it's written close to each other. But looking at the head part and the tail part, one is hydrophilic and one is hydrophobic. So we always break down those parts of the words so we could get to hydro of water. And then one, I always start with one that's more common. So phobic would be more common than philic. Philic will be a little bit more of a jump, but they will get there after they get phobic. So phobic, they think they could have, there's a lot of other words they could connect to, connected to with different types of phobia. So it's fear. I tell you, I always ask my kids, what do they believe, or what kind of connections, or what kind of words do you see or think about? Because all of these water, fear, or all the other examples I've had before, I don't give them the words. I have the kids actually tell me what kind of words they think of and make connections to. And promise you, they have always, someone has always said fear. So then I jump, okay, so what's the opposite of fear? And then they get into the word of love. So here we put together the meaning of being afraid of water and liking water. This relates also again with the cell membrane, but it's with active transport. And this is with exo and endocytosis. Another, I always, here, I have it as a diagram, as a drawing. And then we look at the word exocytosis. So we know what, well, it's part of the cell. So here we have cyto, that means cell. And then I ask my kids, what is happening in this image? What are you doing? What does the word look like? What kind of other words do you think of? I don't think I have ever done this lesson and no one has said the exit. It always comes up. Kids know, they make the connections and they will say exit. And so now we're putting together that in exocytosis, this is the process that the molecules that are being made inside the cell will be exiting the cell. And then we go to endocytosis. So then now they know that cyto means cell, and now we're going to enter. So it's always co-constructing the meaning with your kids. Notice I have never, I don't say front loading. I don't tell them to go look up the word beforehand or copy definitions beforehand. It's looking at an example in context of what we introducing, breaking the word apart together, and co-constructing the meaning of the word together. Now, those were a lot of secondary examples and a lot of like live, well, not live classrooms, but in the short classrooms that I have actually done. I'm going to go through words that are possible entryways for K through 5 and middle school, because science words from K through 12 can, all of them could be done this way. All of them could be broken up into prefix, suffixes, root words, and we could put together the meaning by knowing the different parts. So in second grade, I found words like arrange, but then we have rearrange so that we could do it again. So now you have to rearrange it again. Or assemble, and then we have reassemble. So we already know it means again. So we got to do assemble it again. But then we look at disassemble and think about it as the opposite, or take apart. Same thing with the next word, and you go through this process it's explicitly with the kids, and they will get used to it. They know that this is an expectation of yours eventually. So we have reverse and then reversible, which is the ability to reverse. But then we put it all together with another prefix, and now we have irreversible, which is the ability of not being able to reverse. So you put the meanings of the different parts together and let the kids put those meanings together in order to construct the entire scientific meaning for the use of it in your class. Now, third and fourth grade, I kind of meshed these up because in third grade, you will see thermometer. And if we break it up, we know that it's a tool that is used to measure heat and to measure temperature. By fourth grade, they're looking at words as barometer and anemometer. if I'm saying I did this, we broke words up all the time in my class, and my kids knew I was expecting them to come up with the meaning with me, and I would help them along. Um, so I'll promise you, I will bet 100% sure if I was a fourth grade teacher by the time if I did this repetitively, my kids would tell me, Miss, I'm not quite sure what barometer means, but I could tell you it's measuring something. And I'm like, yes, it is measuring something because and I applaud them because they are halfway to the meeting themselves because they could transfer the meaning of meter, and we thought about thermometer and it's measuring heat. So barometer has to be measuring something, and anemometer also is measuring something because it has this meaning of meter at the end. So just to give you more meaning, I think barometer and anemometer, it's related to either the air pressure and wind speed. That's when we get into earth science in fourth grade. A combination of words here that's going across grade levels from third, fourth, and fifth grade is this suffix of tion, which is describing the state or condition or action of. So we have an adaptation, we have hibernation and migration, evaporation, condensation, precipitation, reflection, refraction, deposition, reaction, classification. So all of these words that have a similar ending, and these are words that are nouns. So I'm going to also plug in the use of language functions here. So I know you guys have seen the language expectations and the language functions underneath language expectations. And so there's one that's across different grade levels and across different subjects. I know it appears in the science, language of science, language functions, and it's nominalization when you have to change a verb into a noun. And this is a great example of that when you have a cactus that has to adapt. And so the adaptation of the cactus are those thorns, or the birds will migrate, and so they have to go on a migration. So it's another way to introduce that opportunity of using those language features, but knowing how to switch a verb into a noun and giving them the examples or opportunity of when to do that. And they would see this suffix over and over and over again. In fifth grade, we have another example of vertebrate. And if they aren't sure what a vertebrate is, I will always include an image. So we have a vertebrate, but then we have an invertebrate, which means nut. So you don't have, or there was no bones for the spinal column, for there was no vertebrae. And then I will always have pictures. I will always include examples, include different organisms. Here we have an insect, a spider, and a mouse. And I ask my kids, well, which ones will have a vertebrae and which ones will be an invertebrate? Same thing with organism. Then we have a microorganism. So why is it we have an organism that's large and we could see, and then we have a microorganisms that are very small? Then I always challenge some of my kids, and I put different prefixes on other words. So I'm like, so if this is a microorganism, that means a small organism. How is micro related to a microscope and a microphone? And I let them think about it, let them give them that wait time so they could process it and make the connections, because a microscope and a microphone aren't small objects. So how does the meaning of small gets incorporated into the use of microscope? Because we have to see a microorganism, and so therefore it gets enlarged for us to see it. Or with a microphone, it will amplify the small sound waves that are there, which is another great tie-in, because in fifth grade, the science disciplines are still um, um, taught in all three. All life science, earth and space science, and physical science are still taught in the same grade level from K through 5. So again, if you have an opportunity to cross the different disciplines, do so, because then we have life science tied into physical science, and we have sound waves versus light waves, and it comes all full circle. So they can make many different connections popping up. Now in 6th grade, we have heliocentric, geocentric, geothermal. I like this prefix of geo. A lot of them by 6th grade will have a connection for it to mean to the earth, to the ground. Thermal heat, so we got the heat from the ground. Centric, we have center for the meaning of the word center. Ik is a suffix that's pertaining to, so we have pertaining the Earth, the solar geocentric is related to the solar system, so it is this the Earth is in the center. Then we look at heliocentric because we have to compare it the two styles or the two models was geocentric and heliocentric. So if we know that in the geocentric model is when the Earth is in the center, I would ask my kids, what do you think helio means? Because if we have center and geo is Earth, what would be helio? Because that would be a less common prefix for them to have come across, because it comes from a root word of being Greek. In my head, I think of one of the Greek mythology gods. But if they are myths, again, they will know halfway it's the center of something, something's in the center, and then I show an image. And then they know that this is the model of the solar system where the sun is in the center, and versus the other model where the earth was in the center. Another topic in sixth grade is with renewable or renewable. So we have new and then renew and renewable. So it's the ability to be renewed. And then we have another prefix where then we could say, well, what if we add the IR and we have irrenewable, and now we have another word. And then it's like instead of the ability to be renewed, now it's the ability of not to be renewed. So they could piece it all together. And then that's talking about renewable or non-renewable resources. In 7th grade, we have the suffix of ism, which is a specific or distinct state. So mutualism, being in a mutualistic state, these are symbiotic relationships that are learned about in 7th grade life science. Parasitism is, or you're in a state of like a parasite. Your relationship is one positive, one negative. And then commensalism is in the state of having the relationship being either mutual, being parasitic, or being having commensalism. I was like, commensalistic, is that a word? So it's when both organisms benefit, one organism benefits, one is negatively impacted, and then and one benefits, and then one stays neutral, just like our example here with the clownfish and the sea anemone. In 8th grade, we have the word combustible or combust, and then combustible, and then combustibility. We have react or reactive, and then altogether is reactivity. But then sometimes we have to also explicitly tell them when we have a double vowel, then the E is usually dropped. The reason why this slide is all together is that in 7th grade, we come across words like homozygous and heterozygous with the topic of genetics, and we have these prefixes that means the same and hetero meaning different, but they will see these prefixes again in 8th grade when they talk about mixtures. So then we have homogeneous and heterogeneous mixtures. So even if it's just transferring the meaning and parts of a word across different words, but also across grade levels. Because as we break them up in one grade, they will come across other scientific words in another grade that will be the following grade level or even in high school. So they're already halfway to the meaning of the word. Now I wanted to do another poll here. So this is with Slido. So if you could go to slido.com, SLIDO.com, and it's the same one from the beginning icebreaker, but it's the code of 28064718, or you could use the QR code that's in the top. I know I went through a couple of high school examples from K through 5, examples in middle school. But are there any other words that you could think of and if you want to input it, I'm going to give you a couple of seconds to join in and add any words that you could think of. Non-renewable is a great example where we have renew, renewable, non-renewable, recycle. And we're going through the cycle again and again. Display. Well, we could definitely split up the prefix of dis and then place. Atmosphere, thank you. Infection, disinfection. Or then infecting, that's an awesome example where then you could replace the other suffix with infecting and disinfecting. Biodiversity is a great word. I see in the chat someone, thank you, antibiotic. That has the bio, it has the anti, subcutaneous, it got a very complex word of subcutaneous. Decomposer, I had that initially on my list too, but I say let me save space, but decomposer is a great word. I can see someone's also in the high school, teaches high school science with hypertonic. We can even go hypotonic and isotonic. Thank you, everyone. And we have one more question if you stay on Slido. Here it is, will you be able to include this type of strategy into your teaching practice? You see if breaking apart words and having kids co-construct meanings of words be useful as a great strategy for your kids and for you to incorporate and give them that time and opportunity to do so. Right, thank you for your input. I'm going to move on to some additional resources that we have available that we have also published from GaDOE. One specifically was focused with language development, content language integration in mind, and thinking about science instruction and also opportunities for language development. We call these the multimodality tasks. They are driven with three-dimensional science, which is really focused in on a phenomenon at the beginning and having the kids figure out why or how it's occurring. And they go through a cycle of obtaining information, evaluating information, and communicating information. And they start off with being introduced with the phenomenon, being introduced with the experience of what's happening, so they could be curious. And then they go through 4 additional stations, and that's a listening station, a reading station, a writing station, and a speaking station, making sure they have the opportunity to work towards all of their language skills. There are 15 that have been published, all in the life science discipline from K through 5, 7, and biology. We have um, in the works a lot of drafts that are being edited for the earth science disciplines from K through 5, 6, and earth systems in high school, and then also a physical science discipline from K through 5, 8th grade, and a physical science high school course. So eventually there will be 75 tasks in all for teachers across Georgia to utilize in their classroom K through 12. In our newsletter, I mentioned joining our newsletter before, but if you join our newsletter, you will see updates when all of these resources are being published periodically. In the winter newsletter, it links up the most recent multimodality tasks, but we also have literacy-based tasks, phenomenon tasks, teacher notes for you to use while you are planning and thinking about the depth and breadth of your core idea. We have phenomena grab and go cards. Ones that have been recently published are for kindergarten, 2nd grade, and 3rd grade. Um, yes, I will drop that link into the chat before we leave at the end of the session for the multimodality newsletter. Now, where you could find a lot of these resources, not just the one on multimodality, but all of the ones that have been published recently and also in the past is on Georgia Inspire. We have our grade levels K through 8 are live. If you go to the curriculum map, it's broken up into different units, and each unit has its standard in parentheses, so you know exactly which one you want to go to and look for. Um, when you go to one of those units, you will see these drop menus. One that I want to highlight are the ones in blue. These are the lessons in particular. And K through 5 have been revamped in a form that makes them editable and user friendly. So you could save the different sections. You could see it as a whole PDF, or you could see the different pieces in a Word document. So you could also um, um, need to modify for your kids' needs, you could do so. Another great feature in Georgia Inspire, if you haven't heard it already, is that if you log in as you through SLDS, you have a save feature as like my favorites lessons, and you could save your individual lessons. Another tab in Georgia Inspire is the standards for each unit, but also in a separate tab, depending on your role. If you're not the content teacher, but if you're the ESOL teacher and you're collaborating with your content teacher, something that you will find useful will be the tab where we have all of the standards. And all of the standards you could go for your particular grade in elementary or in middle school or in high school. And if you go down all the way to the element of the standard, so here we have highlighted 2nd grade science, life science, standard 1, element A, but then we have what is highlighted here in the red circle is the WIDA associations. So if we click on one, you could also expand it And you will see the language functions underneath that language expectations, where kids will have the opportunity, especially if you're addressing this content standard, you can have the opportunity of working towards those same language functions at the same time. Something I always like to plug in is if there's self-paced webinars that are also free for all Georgia teachers. You just have to get a secure portal account, which is available for all teachers. You just have to start at your school level administrator, usually the one that's over testing, because there's a tab in there that's specifically with delivering the access test every single year. But there's another tab that says professional learning, which has self-paced webinars. One that talks about the framework, but also the one that I want to really highlight since I'm the science ESOL specialist is the one about content language integration with science, and it's engaging multilingual learners in science, making sense of phenomenon. Um, and it's once again, it's self-paced. So if you want to break up into different modules, do so. Something else that I also like to highlight is even though we have language expectations and language functions, um, the the previous framework of WIDA had the can-do descriptors, but now they are no longer, and it's the proficiency level descriptors, and they're broken up into the two modes of communication. And each grade level cluster has both continuums. So you have a continuum for the interpretive mode of communication and a continuum for the expressive mode of communication. And it gives you a really good idea of where your goals are for your students at different language proficiency. So keep this in mind as well. If you haven't heard about GaDOE community, this is all these communities are for teachers and led by teachers. We have virtual specialists that are current in classroom teachers, and they post videos every month. Right now, not during the summer months, but they will start back again in August, and they post 1 or 2 videos every month for um, teachers to comment on, to talk about, to discuss. And it also it's another place where it's like a forum of teachers that if you have questions. A couple of weeks ago, I know that there was a lively discussion in the 6th grade science group about resources. So that's another way you could utilize this community of teachers is asking about resources. And once again, this is my email here. I am Laura Canepa-Redondo. I am the Science ESOL Program Specialist at GaDOE. If you have any questions, feel free to email me. If I believe we have a few minutes now, if you have any questions, you could write in the chat and I'll be more than happy to answer. Yes, I see someone commenting on how many resources Georgia Inspire has. It does it has been in the works for a few months, but it's like the new one-stop shop for all content areas. It is fantastic to use it, but it takes time to deep dive in there. You gotta go through all the wonderful resources that are in there. You are so welcome for everyone who's saying thank you. I added the link from one of the slides that was specifically about the Science ESOL resources. You're welcome. Well, yes, all these slides will be available to you. I'm gonna email a PDF version of all the slides to Georgia TESOL, and they will share it out.
Yeah, and then also I want to mention that this the recording of this will go out to everybody that registered. So you also have a link to the recording of this this workshop as well.
Yes, Georgia Inspired does have K-8 resources that are live now. The different buckets are live and accessible. The high school courses are still in construction behind the scenes, but they will be live in the next few months. Oh, the link isn't working. Is it the PDF that I just shared?
Well, I copied and pasted the link and it's working for me, so I reposted it. It's working for me, but
Yeah, share with your science colleagues. Share, share, share. I know as teachers, we always share things. I know I always search and I use things and use ideas of other people's, and we modify. And I share with them. Always share. Let me get another link.
well, I thought also, since if you actually I can send you, if you want to send me the PDF slides to my email, I'll send you my email. I'll put that in the chat. Since I already have a PDF pulled up, I can just add that to the materials that we send out.
Okay.
So when you send me like the PDF of the slides, and I can, because we can, when we send the link to the webinar to everybody, that we can add the links to these materials as well. So in
Okay,
theory, they should work.
sounds good. Yeah.
Okay, so any more questions for Laura? Okay, so thank you all for coming in, for attending this session. I hope you found it useful as I did. I kind of was in my mind. I've got, like, when we get off, I got some ideas, because I'm a associate professor of education / ESOL at Dalton State College. So I'm thinking about this sort of from the teacher preparation sort of side of things. And I've already got some ideas of things I want to do, ideas of activities for my fall classes. So based on, practicing the morphology and prefixes, suffixes, and having them come up with words. So hopefully you all found this as interesting. So just as a reminder, so next week at the same time, same place, will be our final session in this 5th series of integrating content and language. And this session will be on focusing on the content area of mathematics. And so the session will be about making mathematics visible for multilingual learners through key language uses. So thank you all very much for attending tonight's professional learning series, and hopefully see you next week. Thank you very much.
Thank you, everyone.
Thank you. You did a great job.